Well, good evening. If you remember where we were with the 432A repair, I ended up getting everything in the previous video basically wrong, and decided that I should really take the guidance, thou shalt check voltage rails to heart, and come back and look at how we're getting power to the rest of the A2 board. Because if you remember, I can swap out everything. I can swap out the A2 board with a working A2 board, and the chassis, the A1 board, the thermistor, everything works in this unit. So what I thought was, let's come back and take a look at this. So the first thing to look at, I thought, was the power supply troubleshooting. And what it tells you is basically that the plus 7 volt rail should be somewhere between plus 6.5 to plus 7.1, and the minus 13 nominal rail should be somewhere between minus 12 and minus 14. And we know that from the original look at this, that those rails were not anywhere near that. So thinking about that, and let me swap over to the next sheet that I wanted to share. So coming back to the theory of operation, it tells you that for everything is referenced to the plus 7 volt rail. So fixing that rail will then bring us back to being able to look at the other rails. So I thought about the voltage reference. So how is the voltage reference impacting the production? And so what it tells you here is CR7 provides a voltage reference. And if we have a look at what CR7 is, and so let me grab that. You see that CR7 is a 6.2 volt Zener that provides the reference for the rest of the power circuit. So I thought, well, what I should do before I start playing around with other parts of the system. The power supply troubleshooting wasn't helpful with this at all, because it said basically to go start looking at other things. I thought I might measure CR7. Well, when I measured CR7, which actually turns out to be CR6, because it's not unknown for this era of documentation. In fact, it's not unknown for any era of documentation from Hewlett-Packard, Agilent, Keysight, that their text doesn't always match their schematic. So it's actually CR6, saying that that reference should be a 6.2 volt Zener, and when I went and measured it, it was actually 5.8 volts, which seemed to imply that, well, maybe the Zener is off and that's causing the problem. And at that point, I had a look around, the lab here, and I realized that I don't actually have a 6.2 volt Zener. Go figure. So I thought, well, I'll go order one from the local shop. I can head up to Bellevue and go to Vetco and grab something. But while I was at that, I thought, well, what I would do is put the scope on and just have a look at the rails themselves. So let's go do that. So here I have, my scope. I'm going to ground it on the ground point. And then we're going to grab plus 7 volts there. I'm going to turn it on. And now you can see the waveform that it's going. I'm still not going to use ultrascope. Those guys can sod off and take a running thing at a rolling donut. Anyway, you can see there's an incredible amount of ripple in that. And so thinking about it, it's like, well, maybe the problem isn't the Zener reference. Maybe the problem is the ripple that we're getting to start with. And if we have a look, you can see in the video here, we're still very much over here, and no amount, even though I'm here, of manipulating the course adjust will move the meter. So let's take a quick look at what could be causing that ripple. And we get, before we do that, we get similar ripple, as you can see, on the -13 nominal rail here. Interesting point here. Remember how when I showed the 5 kilohertz multi-vibrator bouncing around? Let's take a look at the 5 kilohertz rail, the 5 kilohertz multi-vibrator, and you can see that it's vibrating well, but the bottom line is following that up and down that is occurring from the fact that the rails have that much ripple. So let's turn that off, and we'll take a quick look at what could be causing it. Okay, here we are back again with the schematic of the power part of the A2 board. By the way, the drink of choice today is little Jack Daniels and ice in a corksicle. My wife had used these for wine and stuff, and I'd never ever tried them. I'm sort of liking them because they don't get any dew on the outside of the glass, so there's no water that goes into my coasters and stuff like that. So I'm sort of liking it. Anyway. All right, so if we look at the power supply section just here, what we can see is that there's not a lot of capacitors throughout the entire process. There's a few down here that go to the cinch connectors, but the big one is C1 here, over here, which is 100 nanofarad, 100 microfarad, sorry, electrolytic that's across the rectifier. So that's most likely what's causing the problem. So let's take that, and in fact, if we have a look, you might be able to see it. It is this silver guy here. It's probably a Sprague. Let's take it out and then give it a test. So I'm going to make sure we're turned off, and let's do that. Okay, to take it off, I'm going to use my Heiko FR301. If you do a lot of through-hole work, it really is worth it. So let's just jump in here. Okay, there we go. We've taken the 100 microfarad axial capacitor out. So let's give it a test. And what I have here is I have the classic LCR meter, the DE 5000. So let's calibrate that and then give it a test. Okay, so we're all calibrated now. Let's drop in the capacitor. We will put the negative on the negative, the positive on the positive, and wait for it to think about it. And it's registering, 900, let's call it 1 microfarad. It's supposed to be 100 microfarad. So, irrespective of any of the other settings, this electrolytic is clearly dead. So, what I want to do now is to replace it with an electrolytic that I have. So let me go away and take a look at that. All right, well, I took a look. I have a very limited range of axial. These are the axial capacitors. So I have nothing that is close to 100 microfarads. What I do have is a radial capacitor, that electrolytic capacitor. There's 470 microfarads. Now, because this, if we remember, if we go back and have a look at the schematic, it's just really filtering across the rectifier. So it shouldn't really matter very much what value it is, as long as it's above the 100 microfarad and the voltage specs, match. So let me go and put that in, and we'll see what happens at the end of it. Okay, so here we have the 470 microfarad capacitor in there. So let's drop this into the unit. Sort of have to get it in under the rails. Okay, so there we have it in. I've been a bit careful to make sure that it's not touching any of the circuit traces, because there's no solder mask on this. Is all gold plated. This is classic Hewlett-Packard gear of the era. So let's turn it on and see what happens. Okay, well that seemed a little different. Let's check the rails. Let's just turn this on, bring it into shot, so we can check. This is going to be minus 13. That's minus 12.5. It's close enough. It's plus 7.7. All right, that's a little high, but it is much better than what it was. So now let's take a little look and see what that ripple looks like. So we'll put this back on ground. Now let's have a look at 13 volts. And you can't quite see that there, but you'll see all the ripple is gone. So let's try the 7-volt rail, and you'll see the ripple is gone. So now let's take a quick look at the multi-vibrator. Remember, that was bouncing all around. And now we're seeing, and if I hit auto on that, we're seeing quite a nice stable multi-vibrator. So if I take this out, let's go take a look. Now let me move the camera a bit. Okay, now you can see the meter, and I'm not getting any movement now on the meter. All right. Well, oh, no, there we go. I was at one end of the course adjust, and now you can see that I can actually bring that course adjust right back down, and then I should be able to fine adjust that back. We got a little parallax error there, but hey, it looks like I've got the meter close to a working situation. So what do I need to do? Well, I need to obviously replace that 470 with a 100 mic axial, and then we'll go and start looking at the rest of it. We'll reinstall the course adjust, and I need to wonder about why the 7-volt rail is at 7.3 volts instead of 7. But given how sensitive the unit is to the ripple that's on the line, I'm wondering if maybe it's 7.3 because of the 470 microfarad capacitor. So let's get 100 in there, and then we'll take a look at it. Anyway, we're one step closer to working this out. Hope you enjoyed it, and I'll see you again next time. Thanks very much. Bye.